Hi everyone, so I'll be going through the 2021 Northern Hemisphere Further Maths Exam 1. So for question 1, the matrix expression is equal to, so basically all you have to do is enter these matrices into your CAS and you'll get this solution. So it's a pretty straightforward question. Question number 2, consider the following four matrices. How many of these matrices are diagonal matrices? So somewhere in your notes you should have the definition for a diagonal matrice. So definition is a leading diagonal going downwards from left to right. All other elements should be zeros. I've got an example here. So basically, if you look at the other matrices, the only one that has a leading diagonal going down from left to right with all the other elements surrounding it with zeros is this one over here. So therefore, there's only one, and B is the solution. So for question 3, the matrix equation has a unique solution for x and y. Which of the following matrix equations has the same unique solution for x and y? So to do this, you need to solve for x and y for the given matrix equation in the question. So to do this, you make x and y the subject and raise the square matrix to the power of -1 and multiply this by the 2 by 1 matrix 15, 4. And you should get 17 on 5 and 7 on 10. So to find the solution, you should solve for x and y, try to find the solution for x and y for any of these multiple choice questions. If you do it for D, you solve the equation the same way as you did for the matrix given in the question. You should get x and y equals raise the square matrix to the power of -1 and times that by the 2 by 1 matrix, and you should get 17 on 5 and 7 on 10 for x and y, and therefore that D is your solution. So for question number 4, matrix M1 is the 5 by 1 column matrix. The second 5 by 1 column matrix M2 contains the same elements as M1, but the elements are ordered with the largest value at the top and the smallest value at the bottom. Matrix M2 equals P times M1, where P is a permutation matrix. Matrix P is one of the following multiple choice solutions. So P is a permutation matrix, so instantly you can get rid of this matrix over here and this matrix over here, because a permutation matrix must have only one in each row and column, and all the other elements should be zeros. But these ones have like 3 and 4, so therefore they're wrong. So the solution is either A, B, or C. So if you multiply one of these matrices by M1, you should get you should try to get a matrix that has if you multiply one of the matrices A, B, or C by M1, your solution should have the numbers ordered from largest at the top and smallest at the bottom. So if you try matrix C and you call that P, so P times M1, and you do that on your calculator, you should get 25, 15, 12, 9, and 3. And therefore, C is your solution. Question number 5. A factory employs the same number of workers each day. The workers are allocated to either the green building or the white building. The workers may be allocated to work in a different building from day to day as shown in the transition matrix below. The green building must have 36 workers each day. Each day the number of workers in the white building will be. So to find the number of workers in the white building, the question indicates that the steady state has been reached because the factory employs the same number of workers each day. So that means there'll be 36 workers at the green building each day. So to find the number of workers at the white building, you raise the transition matrix to a high number, so for example to 50, and you get the following matrix. So so to get the number of workers at the white building, you do 0.33 times an initial number of workers equals 36, because there's 36 workers at the green building each day. So if you do that, x equals 108. And then to find the number of workers at the white building, we have 0.66 here. So you do 0.66 times 108, which will give you the number of workers at the white building, which is 72. Therefore, C is the correct option. Question 6. 4 families visit an amusement park. At this amusement park, there are 3 rides: roller coaster, Ferris wheel, go-karts. Each ride has a different ticket price for adults and children. The number of tickets that each family pays is shown in Table 1 below. And the data in Table 1 can be converted into a 4x6 matrix V. The ticket price per ride is shown in Table 2 below. Data in Table 2 can be converted into a matrix W, where W equals the following matrix. And RA is the ticket price for one adult to ride the roller coaster. RC is the ticket price for one child to ride the roller coaster. Matrix product VW produces matrix L. The elements in matrix L show the cost of one of the following multiple choice solutions. So to do this question, it says that V is multiplied by W. We know V is a 2x6 matrix, which is this data in the table converted into a 4x6 matrix, which is multiplied by W, the 6x2 matrix over here. And when you multiply these two matrices, you get a 4x2 matrix. But we have to know what elements, or what the elements in this 4x2 matrix actually represents. So if you draw 4x2 matrix out, so when you multiply matrix V by W, you'll get a 4x2 matrix, and the elements will represent the total cost of adults for family 1, children for family 1 as well. So basically, you'll be getting a matrix that shows all adult tickets and all children tickets for each family, because you'll have the cost of adult tickets here, cost of children tickets here, cost of adult tickets for family 2 over here, cost of child tickets for family 2 over here, and so on. So basically, therefore, C is the correct answer. You may think B might be right, but B is wrong, because it only says that all adults tickets and all child tickets at the amusement park. However, the matrix actually shows the cost of the adult and child tickets for each family. Question 7. Each day, all employees of a large company will work at one of the 4 locations: L1, L2, L3, or L4. The table below shows the number of employees at each location every Monday. So I've just converted this table into a matrix over here. The transition diagram below shows the change in the number of employees at each location from day to day. So I've also converted this diagram into a matrix, transition matrix over here. So which one of the following statements is true? So basically, I found the number of locations, the number of employees at each location on Tuesday, Wednesday, and Thursday by performing the following matrix multiplications. So basically, it's just a process of an elimination. So for A, on Tuesday, there will be no employees at location L2 only. That's false, because there's actually no employees at L4 only. On Tuesday, there will be no employees at location L2 and L4. No, that's true. That's false, because there's actually 35 employees at L2. So B is false. On Wednesday, there will be no employees at location L4 only. So Wednesday here is over here, and then there will be no employees at L4 only. That statement is false, because there's also no employees at L2. So C is false. If we go to D, on Wednesday, there will be no employees at location L2 and L4 only. That is true, because if you look at the matrix, there is no employees at L2 and L4 only. So therefore, D is correct. Question 8. 4 teams, J, K, L, and M, compete in a tournament. Each team plays one game against every other team. In each game, there is a winner and a loser. To decide the winner of the tournament, the sum of the one-step dominance matrix, D, and the two-step dominance matrix, D squared, for this tournament is determined. The sum of D plus D squared is shown below. The 2 in the second row shows the total number of one-step and two-step dominances that Team K has over Team M is 2. In the first 2 games, Team J defeated Team K, Team L defeated Team M. Which of the following is the correct one-step dominance for this tournament? So basically, of the multiple choice options you have, A, B, C, D, or E, one of these matrices is going to be D. So basically, the best way to do it is probably just use trial and error. Sub one of these matrices into the equation D plus D squared, and if you get the following matrix, then you know that that matrix is a one-step dominant. So basically, if you try option A as your solution for D, D plus D squared will give you the following solution over here, and therefore A will be correct.